Hello everyone, welcome to the next lecture on the real analysis. Today we will discuss about PY question series on sequence of the real number. Myself Dr. Harish Garg. You can simply follow my YouTube channel where there is a playlist you can see on the CSIR NET. We have discussed already the PY question series on the topic wise such as infimum and supremum, that's the last lecture, complex analysis, Mobius transformation, improper bounded variations, linear algebra, many more are available in this playlist. Also you can see some statistics lecture like testing of hypothesis, inner product, hazard rates, base estimator, heat wave, Markov, all are available in this PY question series. So what is the objective is we will cover all those 25 plus questions related to the CSIR NET 11 to 23. I will cover all those parts only related to the sequences. Remember, for related to the infimum and the supremum, that is I already uploaded in the last lecture. So I will cover all those questions which shows that whether the sequence is convergent, bounded, monotonic and many more in this lecture. So before I give you this directly to the PY question series, I will give you some tips which will help you to solve the PY question series or any of the exam in a very simple manner. So what is the first tip is, if you want to prove any of the sequence to the convergent, find this limit of an if this exists and unique. That is the most important word. If the limit is not unique, then you can say the sequence is not convergent. Fine. For example, if I say here, definitely we know the limit is existence as either 1 or -1, but it is not unique. Once it is not unique, then you can say the sequence is not convergent. This is one way you can prove the sequence is convergent or not. Another way, if you prove that, or if you find that sequence has more than one limit point, like again of this, so definitely the limit point of this is 1 and -1. So clearly say it has more than one limit point, so it is not convergent. Like in our last lecture we have discussed, whenever you have -1 raised to power n, you always break into the even and odd terms. And if you get more than one, or you can say the limit sup is not equal to limit of infimum, then it has not a convergent. Every convergent sequence is a bounded sequence, but converse is not true. Again you have this example. Clearly say this is my bounded sequence. Fine, it lies between +1 to -1, but it is not convergent because the limit is not unique or it has more than one limit point. Every convergent sequence is always a Cauchy sequence, but converse is not true. Whenever you are talking about the real, that is on the usual metric space or the called as the R, then a sequence is said to be the convergent if and only if it is Cauchy. But in general, it is not true that every Cauchy is a convergent. Whenever you have a Cauchy sequence, if you prove that a Cauchy sequence, then it is always a bounded. What does the converse of this? It means it is, if the sequence is not bounded, it means it is not Cauchy. Fine, the converse you can easily move on that. Similarly from here, every Cauchy sequence is bounded. If it is not bounded, this implies it is not convergent. Every sequence has a subsequence of itself. So if you have a sequence an and if you have nk, that's a subsequence, it is itself one of them is the subsequence is the same of this. If you prove that the sequence an converges to the L, and this L must be the limit of an and it must be the unique and existence, then the subsequence is also converges to the same limit. The converse is true only when you have the word of the same limit. If you have the subsequence an1, if you have the subsequence an2, if it converges to the L1, if it is converges to the L2, and if L1 is equal to L2, then only you can say the original sequence is my convergent. However, if L1 is not equal to L2, then this is not convergent to either of them. If an you prove that it's a divergent to either +∞ or -∞, then the subsequence is also divergent to +∞ or -∞. Every sequence has a monotonic subsequence. Although whether the sequence is a monotonic or not, but it has a monotonic subsequence. A monotonic sequence is a convergent if you prove that it's a bounded. What is the meaning of that? Monotonic plus bounded, this implies is a convergent. a convergent sequence need not be bounded. So that's a very simple trivial cases argument, because if it is a monotonic, then you can say it's a bounded as well, but if it is not a monotonic, then you can easily say it is not a bounded. Monotonic sequence can have at most one limit point. That's the most important concept for you. And the last concept is every bounded sequence in R contains a convergent subsequence. Now, based on this kind of the shortcut tricks, I can solve all those 25 plus question within a 10 second you can see in this lecture. So before I go to the quickly on the PY question, if you want to find more shortcut tricks, you can simply scan and join my WhatsApp group, and I will add you in my group and we can discuss more in this. Now let's start with this video. What is the given statement is AN and BN are my two monotonic sequence. So what is the meaning of the monotonic is either it is increasing or decreasing. It is not given to you. So that means you can consider any of the sequence which is either a convergent or either is a monotonic increasing or decreasing. But the condition is summation of AN and BN is my convergent. Then series is also convergent or not. So look at that. If I consider one of the series is my 1 over sequence is my 1 over n, it's a monotonic, fine. If I consider the Bn is my again 1 over n, fine. What is the meaning of that? Then what is the An into Bn? Clearly say this series is my convergent by P test, but the series of An is divergent, but he said convergent, is option is wrong. At least one of them is convergent, but here both the series, this and this series are my divergent, so this option is also cancelled. An is bounded, Bn is bounded. So can you think about any of the unbounded sequence? Fine. If I say n and our target is to consider this also is a convergent. When the series is convergent, whenever P is my greater than 1. So if I consider here, then it must be of my n cube. So this implies A and Bn is my convergent. Fine. This is a monotonic sequence. This is a monotonic sequence. Now An is bounded, wrong. Bn is bounded, yes. This is bounded, but this is not bounded. So at least one of the bounded is the right answer of the problem. Now look at this next question. If xn is my convergent sequence, yn is my xn is convergent sequence, yn is my bounded sequence, then your target is to check which of the following is true. Look at that. Every convergent sequence is my bounded, fine, on the real R, fine. So if xn is bounded, yn is bounded, what does it mean? Xn plus yn is my bounded, so it means this is my correct. But if yn is my bounded, it doesn't imply that it is convergent, so it means the sum is not convergent, fine. Or the second method is you can choose any of the sequence xn which is convergent. So what is the meaning of the convergent is limit is unique, fine. So what is the easiest way you can find the limit? That is a 1 over n is a convergent. What is that? It is a bounded. So I can say this is a my bounded. Now therefore what is the xn plus yn? It is 1 over n. So clearly say this is my divergent sequence, because the limit of this is not unique and it is a bounded. So this first option is cancelled, second option is correct option. Xn plus yn has no convergent subsequence, no convergent subsequence. So this is my xn plus yn. If I consider this, what is the subsequence of this? The subsequence of this is my 1. So clearly say this has a unique limit. Once it has a unique limit, so it means it has a convergent subsequence, but he said no, this option is cancelled. No bounded subsequence. This is a bounded subsequence. If I consider this is a subsequence, it is a bounded, it is bounded by 2 and 1. So this option is again cancelled. He said no. Right answer is B is my correct option for this example. Look at this one. Xn is the sequence of the real number satisfying this property. Xn minus this is less than epsilon. Now always remember student, you always consider the two examples in your mind whenever you discard the options for the sequence, this or here. Fine. Now you can see I need this one is less than. So if I consider xn to be root of n, this is on the real number r. Fine. So what is that? This is my n plus 1 minus of root n. So what is that? I can rationalize them. It will be my this case. So clearly say this will approaches to the 1 by 2 as n approaches infinity. Fine. No, it will approaches to the 0. As n approaches infinity, it goes to the 0. That means it is less than epsilon. So this property is hold for the sequence xn is root n. Now look at the option. Is this a bounded sequence? Or firstly, is it a convergent sequence? It is a divergent sequence. So once this is a divergent sequence, what does it mean? Third option is my cancel. Fine. Is it a bounded sequence? So clearly say this is my not bounded. So it is a bounded, is a cancel. Once it is not a bounded, also we can say it is not a convergent. Once it's not a convergent, and on the R it is not Cauchy. Fine. So it's a Cauchy, it's again a cancel out. Then it is not necessary bounded. It's not a bounded, it's not necessary bounded. It's the only left option. So that's why this is my correct answer. So it's a bounded, it's a not a bounded, it's a Cauchy, but it's not a Cauchy, it's a convergent, it's not a convergent. So that the right answer is, last option is the right answer. Xn is a sequence of the positive real. Xn is any sequence, either it's a bounded, it is not given to you, either monotonically increasing or decreasing, or it's a convergent or divergent, not given. So it's on you, you can choose any one of them. Which of the following statement is true? Xn is convergent if yn is convergent. Okay, I can start with here. I can choose any of the sequence which is not convergent. This is clearly say it's not a convergent. What is the yn? It is my n over 1 plus n. So it will goes to, as n approaches infinity, it goes to the 1. So clearly say this is my unique. So what is the meaning of that? Sequence yn is my convergent. So if yn is my convergent, fine, then xn is my convergent, but clearly say this is my divergent. So first option is cancel. Fine. If xn is xn is convergent if yn is, okay, firstly you can say bounded. Again you can see if xn is bounded but it is unbounded, if yn is bounded, so clearly say yn is n over 1 plus n is my bounded sequence. Fine. So this property is satisfied. Then he said xn is also bounded, but clearly say xn is n is my unbounded sequence. So this option is also cancelled. Now look at that. If xn is my bounded, it means it lies between here, or if I choose xn is my 1 over n, for example, it is lies between a and b, that means 0 and 1. Then xn is less than of the 1 plus xn from here. So clearly say the ratio is less than 1. Fine. And xn I can choose it's a over something, so that is a greater than 0. Fine, because it's a positive real number. So what is the meaning of that? It is bounded. What is that? It is a yn. So if xn is bounded, yn is also bounded. Now if xn is my convergent, it implies bounded. Yn is convergent, bounded. So that's again the same target for you is the right answer. Fine. So you can see the B and C are my right answer of this. So it's simple. You think about the any of the divergent or unbounded sequence. Look at this one. An is a sequence of the positive numbers such that is here. What is given to you? Ai's are my greater than or equal to 0. What is the meaning of this? A1 is greater than of this. It means Ai's is my decreasing sequence. That means it is monotonic. Fine. Now you can think about any of the sequence which is decreasing. So that is my 1 over n. Fine. But yes, it's a decreasing, but now it's a fine. Now what is the limit is 0. Fine. But if I change them to be say 3 plus, then what is the limit of this an? It is 3, which is non-zero. First option cancel. Look at the second option, an over n. So 3 over n, 1 over n square, it goes to the 0. But we can't say from this example. An over n, series an over n. So 3 over n plus 1 over n square. So I can say this is 3 over n plus 1 over n square. So clearly say this is my divergent by p test, and this is my convergent. So if one of the series is divergent, it implies it is divergent, but he said convergent. This is cancelled. Then how you can prove that here? Now it is already a monotonic decreasing. AIs are my positive, so it is a bounded also. It is a bounded below. Fine. And it's a monotonic decreasing. What does it mean? This implies the sequence is my convergent. Fine. If the sequence is convergent, what does it mean? If the sequence is convergent, it means it has a finite limit. So if you take the limit of an over n, it has a finite limit over n. So what is the limit of n approaches infinity? It goes to the 0. So that is the correct answer. An over n square is my convergent. So how you can prove that it's a convergent? So I know an is a decreasing sequence. Fine. So an is always be less than of my a1 or a2. If I divide it by n square on the both side, then if I take the summation on the both side, this is my convergent by p test. So therefore by the limit comparison test, this is also convergent. So the right answer is B and D are my right answers. If Pn is a polynomial, is a quadratic polynomial, and are the distinct root of this, okay. Remember, if fx is my polynomial of degree n, fine, these are shortcut tips for you. If fx is a polynomial of degree n and there exists n distinct root, fine, if fx is a polynomial of degree n and if there exists n distinct roots, then the limit of the fx and the limit of f dash x is always exist. Fine, for all x in my domain. Now look at that. It is, so what is the given to you? Pnx is my quadratic polynomial. So once is a quadratic polynomial, we need a two distinct roots. So clearly say it has you have a two distinct root. So it means this property is satisfied. So what is the meaning of that? Limit of Pn and limit of Pn dash exist. So clearly say the first and second options are correct. Look at this one. Now since lambda naught, these are my distinct real numbers. So clearly says this divided by 3 are also belongs to the R. So and we know it is for all R. So therefore limit of Pn of this also exists. Fine. But he said does not exist. So this option is cancelled. Again he said derivative does not exist. That's the wrong option. A and B are my correct answer. Simply remember these shortcut tips for you. Okay, look at this another one. Again Pnx is my quadratic polynomial. Fine. And this and this are my distinct root. So it's a quadratic polynomial, we need a two distinct roots and it is given to you. So therefore such that this and this exist. Fine. Then clearly say the limit is existence for all x, derivative is existence for all x, lambda naught and lambda 1 is by part of their real numbers. What does it mean? The sum of them is also the part of the real numbers. So it is does not exist is the wrong option. Why? Because I said it is existence for all x belongs to the R. So that means this is does not exist, this is does not exist, cancel out. Again A and B are my right answer for this problem. Look at this one. A and B are my natural numbers such that this property hold. Okay, very simple. Look at that. Firstly, I can choose A is equal to B. I can choose A and B as a 1, and n must be greater than of this. So as n approaches infinity, so then what is my dn? nc1, nc1. So what is that? It is my 1. Therefore, what is the limit as n approaches infinity? It is my 1, which is unique and existence. What does it mean? dn is convergent. So dn is convergent, correct option. Look at this one. A is less than B. If I choose A is my 1, B is my 2, fine. Then what is my dn? nc1, nc2. So it is my n minus 1 over 2. So it is 2 over n minus 1. It goes to the 0 as n approaches infinity, which is again unique and existence. So this is also convergent. If I choose A is my 2, B is my 1, then what is my dn? nc2 over nc1. So that's a n minus 1 2 into n minus 1 over 2, which goes to the infinity. What does it mean? It is divergent. Fine. dn convergent for all A and B, but clearly say whenever this, for this case it is not divergent, it's not convergent, this option is cancelled out. B and C are my right answer. Always consider some particular examples, because A and B can have any natural number. You can take as B, A 7, B is equal to 9. It's on you. Fine. Look at this another one. Xn is a sequence of the positive real number which of the following statements are true. If the two subsequences are convergent, then always, as I told you, you always consider the two examples. One, this. Okay. Think about which one is a fit for this problem. Subsequence. Now it's a even and odd. Whenever there is a question of the even and odd, always think about here. If I consider x of n is my minus 1 raised to power n. What is this? X of 2n is plus 1. X of 2n plus 1 is minus 1. So clearly say the limit of this goes to again a 1. It goes to the minus 1. It means this is my convergent. Fine. So if the two subsequence convergent, this property is satisfied. Does this also the convergent? Not. This is a divergent sequence because there are the two limit points, or the limit is not unique. So it means it's a false option. Again, if I consider xn is my minus 1 raised to power n, then what is that? This is minus 1, that is a 1. It is a constant series. It is a convergent. Fine. Then the sequence xn is convergent. Clearly say this is my divergent. Look at this next one. If limit is existence, then of this. Do you know any of the result which correlate of this one? Yes. Anybody? Yes. This is a Cauchy second theorem on the limit. This is a Cauchy second theorem on the limit. If I take the limit on the both side, if this existence, that means if I consider this is L, then this is my, so what does it mean? Limit is existence. It means it is my convergent. Fine. That is sequence xn raised to power n is my convergent. If it is convergent, then it implies my bounded as well. So this is my correct option. Look at this one. If xn sequence is my unbounded, then every subsequence is my unbounded. So what is the meaning of the unbounded? You have to think about here. Fine. If I take the sequence as a n, this is unbounded. Can you consider any of the subsequence of this? So yes, you can easily take the subsequence like of 2n plus 1 is my 1, or you can consider the even sequence is only 1. This is my subsequence, and you can see it is a constant, so it is a convergent. Once is a convergent and this is a unbounded, but he said every subsequence is unbounded, but this is a bounded sequence. So that means this option is cancelled. So therefore the only right option is my C is the correct answer. If the sequence is unbounded, if I consider this is my unbounded sequence, then every subsequence of this I consider the odd sequence, then it is a bounded sequence. Okay, look at this another one. An is given to be here. You have to find the limit of an. So firstly I can integrate this part. So it is a minus 2 over minus 2 n to n plus 1. So minus 1 over 2 I can take as a common, n plus 1 square minus n square. So if I take the LCM, it is n square, n plus 1 square. So minus I can adjust is a 2n plus 1. This is my an. Then I can take the limit, I can multiply by n into c and then take the limit as n approaches infinity. So I think very simple. I can start from the option, say any number greater than of the c 3. I can choose n is equal to, c is equal to 4. Then this value will be n4, 2n plus 1, 2n square, n plus 1. So what is the degree of the numerator? Degree of the numerator is 5. Degree of the denominator is 4. So definitely degree of numerator is greater than of the denominator. It goes to the infinity. Fine. Always remember students, whenever the degree of numerator is greater than of the degree of denominator, then as n approaches infinity, this goes to the 0. Whenever degree of the numerator is less than of the degree of the denominator, then the limit will goes to the 0. Whenever n is equal to 3, when you substitute n is 3, this will be cancelled out. It's a n 2n plus 1 over 2 n plus 1 square. Now the degree are same, so I can divide it by n square on the both side. So it will be 2 1 plus n square. So the limit will be my 1. So this is my 1. This is wrong. Last option, take any number in between them. If I choose c is equal to 1, then it will be n 2n plus 1, 2n square, n plus 1 square. So clearly say that degree of numerator is 2, while denominator is my 4. So this limit will goes to the 0. So hence this option is cancelled. Only the second option is the right answer. Okay, if x0 is my here, okay, you have to check whether this is or not. Okay, I called is a journal in form alpha times xn minus 1, beta times xn minus 2. Then the limit of this xn as n approaches infinity is always goes to the beta times x1 plus x2 divided by alpha plus 2 beta, provided alpha plus beta should be 1. Alpha plus beta should be 1. So if I look about this expression, I can written this term also in term of here plus beta times xn minus 2. So what is the alpha? Alpha is the coefficient of this, it's a half, beta is my half. Fine. So this sequence is always convergent. Fine. Now look at that. What is the answer of this? Limit of xn as n approaches infinity, beta is my half, x1 is my 0, x2 is my 1, alpha is my half, and of this. So what is the right answer? 1 over 3 over 2, that is 2 over 3. So limit is my cancel, limit is my correct option. Now what does it mean? If limit is my finite, what is the meaning of that? Sequence is my convergent. Fine. If the sequence is my convergent, but they are not talking about this. So if sequence is convergent, then what is the meaning of that? It is Cauchy as well. Fine. So sequence is Cauchy as well. Now why is a Cauchy? Because you can easily see, in other words, whenever you are written here this form, what is that? I can say xn minus 1, xn and xn minus 2 are in AP or arithmetic mean, and x2 is a greater than of x1. What is the meaning of that? Xn minus 1 is greater than xn is greater than of xn minus 2. Fine. So what is the meaning of that? It is monotonic. Also x1 is my fixed number, so it is also as a bounded. Fine. So why is a bounded? Because clearly say x2 is my greater than of x1, so I can expand them. It's a monotonic and bounded. Once it's a monotonic and bounded, it is convergent. Otherwise you can simply find the limit is my unique and existence, so it's a convergent. Fine. Now xn is a monotonic sequence. Yes, it's a monotonic sequence, so therefore the right answer is monotonic, Cauchy and here. So A, C and D are my correct answers for this problem. xn is a monotonic sequence. Look at this next one. Lambda n is given to be here for some n, then this does not exist for some n. I can firstly integrate this. What is the integration of this? It's a minus n plus 1 over 1 minus n from 0 to 1. So it will be my 2 raised to power 1 minus, and it is a 1 over. Fine. This is my lambda of n. When it will not be does not exist. So clearly say it exists for all n, but we have to check at n is equal to 1. So what is the limit as n is equal to 1? It's a infinity over it's a 0 over 0 form. 2 raised to power 0 is 1 over 1, 0 by 0. So I can apply the L'Hopital rule. It is ln 2 minus 1 divided by minus 1. So this value will be cancelled. As n approaches infinity 1, it will be my 2, which is existence. Therefore this is existence for all n in my natural number. So it does not exist, cancel out. This does exist for each n, and the sequence is unbounded. This exists for them, the sequence is bounded. Now how you can check whether it's a bounded or not? What does it mean? The limit in each case is a finite. So what is this? It means the sequence is my convergent. Once the sequence is convergent, it implies it is my bounded. So it is unbounded, cancel. This is the right answer. Now how you can find this one? So we all know this value by the Cauchy's second theorem on the limit. We can write this term as of here. Fine. This is the same thing. Now I can substitute the value here. What is that? N plus 1. If I substitute n plus 1, it will be my minus n minus 1. It will be my n plus 1 is my minus n divided by 2 raised to power 1 minus n minus 1 of 1 minus n. Now you can see as n approaches infinity, what is that portion? This portion will be my minus 1. Fine. And for this portion I can divide it by 2 raised to power minus n divided by 2 minus 1 over 2 raised to power minus n. So as n approaches infinity, this value will be goes to the 0. Is this correct or wrong? Is a 2 raised to power minus n. I can just wait. I can take n. What is the n? Lambda plus 1 is 1 minus this and divided by n plus 1. So it's a n 2 raised to power minus n over this and here. So what is the limit for this value will be? If I take this value, it's a just wait. I can written clearly. I can written this is 1 over 2 raised to power n minus 1 and 2 over 2 raised to power n minus 1. Fine. Now take the limit as n approaches infinity. This value will becomes my 1. This value becomes my 0. So 0 minus 1, 0 minus 1. So it is my plus 1. And he said the same limit. So C and D are my correct answers. Okay, an is my bounded sequence. You can consider this. You can consider this sequence are there. Subsequence is convergent. Okay, you think about any of the subsequence, any of the bounded sequence. So any of the bounded sequence is my here. Every subsequence of this is my convergence. Is it correct? It is wrong. If I consider these two are my subsequence, if I consider this is my multiple of say 4 and this is a multiple of 3. So clearly say, is they convergent? No. Why? Because if I say what is the subsequence limit of 12? 12 is a multiple of the 3 as well as multiple of 4. So it has either 1 or -1, not unique limit. Fine. So it means it is a convergent, is the cancel. There is exactly one subsequence of an which is convergent. That's wrong. Why? Because if I consider the subsequence is again a 1 and -1, here n is my odd sequence and n is my even. So definitely whatever the number you have to taken 2n, it is always -1, and 2n plus 1 is always +1, which is a unique limit. So therefore this is every subsequence. How many subsequences have we get? We get a 2 subsequences which is convergent, but he said exactly 1. This option is cancelled. There are infinitely many subsequences for this. Yes, definitely I got a 2 if I define the another one is say 1 for prime numbers and many more. So definitely it is my infinitely many. There is a subsequence an which is convergent. How you can say that? There is a subsequence. Yes, you can find a subsequence like of, I can define the subsequence is my 1. This is a subsequence of this which is a convergent. Yes, this is a convergent. So C and D. There is a subsequence. So yes, fine. C and D are the correct options. Okay, define the sequence an of the Fibonacci numbers such that an is an minus 1 plus an minus 2. Then the dimension of this R. So what is the dimension of this? I can use the rank nullity theorem. Fine. So I can return this is number is in this manner. Fine. What is the rank of this line? If I consider this is my x minus y minus z is 0. Fine. What is the rank of this? If I code as S, what is the rank of this S is 1. Nullity, and your dimension is you have to find the nullity. Fine. So what is the nullity of this S? Dimension minus rank of the S. How many vector you have? 3 minus 1. So it's my 2 is the right answer. There is one more way. How many vectors? How many vectors you have, or how many variable you have? 3 minus number of conditions. How many conditions you have given? Only one condition. 3 minus 1 is 2 is the right answer. If you want to find some more detail about how you can find that dimension, I recommended you can watch my previous lectures on this one, basis and dimension. You will learn a lot with the help of the various shortcut tricks how you can solve the dimension of the problem. Look at this another one. Consider the sequence of the rational numbers Qk such that this is given. Q is bounded, convergent, or okay, fine. How you can find the sequence is convergent or bounded? If I prove this number is less than of something, that it implies it is bounded. Fine. Now look at that. If you look about this 0.1, 0.101, clearly say this number is my less than of 1. So what does it mean? The sequence xk is my bounded. Fine, because if you look about that, whatever the value of k, it is always be less than 1. So it is a bounded. Fine. So it is not bounded. Option cancel. The sequence is bounded. Fine. Sequence is bounded. Now when it will be convergent? Now look at that. If you look about this qk, what kind of this series is there? 0.1, 0.101. It is a, what is that? It's a non-repeating series. It's a non-repeating decimal expansion. Fine. Also you can say it's a non-terminal. Fine. Whenever any sequence will satisfy this non-repeating here, what is the meaning of that? This sequence is always a convergent. But the question arises, is always a convergent. So now it's a convergent to Q or not? It is always convergent to the irrational number. Fine. Now how you can say it's an irrational number? So what is the meaning of that? Q is not a irrational. So this option is cancelled out. is not convergent in Q, fine, because it's convergent to the irrational number. So that's a correct statement. Bounded. Now the only thing you have to check about the Cauchy. Remember, it is not R. If it is R, then Cauchy implies convergent and vice versa, but it is on the R. So what you can do, look at that. Now is the only target to check whether it's a Cauchy or not. Take any subset of the R. Say A is my subset of the R. Fine. Now if you prove any of the subset, if any of the sequence is convergent in this subset, then it implies it is a Cauchy. Fine. On R it is fine, but if it is on the subset, then you have to firstly prove it's a convergent, then it is a Cauchy. Now look at that. This is my rational number. Q is the subset of R, and we prove or irrational number. If I say Q complement is a subset of R, I prove QK is the QK is my sequence which is convergent in Q complement. So it means it is also Cauchy in Q complement. So it is not a Cauchy. That's a wrong statement, because it's a Cauchy sequence, but Cauchy in irrational number, and Cauchy is the correct option. Not convergent in the Q is the right answer. Only option is the left, is the D is the right answer. Look at this another one. Again, alpha is my 1 0 1 1 0 1 1 0 and so on. Be the real number to the base 10, and is my here. Choose which of the following is the rational, irrational, fixed, and here. What is the meaning of that? If you can see, I can prove the bounded by this manner. Also you can see it's a convergent, so every convergent sequence is my bounded. Fine, so it is also the bounded, but I already taken from here. Okay, what is that? Again, alpha is my non-repeating, non-terminal or non-terminal decimal expansion. Fine, so what is the meaning of that? Alpha is my irrational number. Fine, because it's a convergent and convergent to the irrational number. So it's A is a rational number, cancel, is my correct option. Alpha is a no periodic decimal expansion. How you can say it's a, okay, that's again is you can see it has a non-repeating decimal term expansion. Is again meaning is that alpha has no periodic decimal expansion, because it's a non-terminal. So clearly this option is correct. Look at this one. For every Q greater than of 2, so I can choose Q is my 2. Fine, there exists some R. Fine, I can assume. Okay, if Q is equal to 2, then this expression will be R over 2 is less than alpha. Alpha is my here, and it will be R plus 1 over 2. Fine. Now look at that. What does it mean? 0.5 times R is less than of 1 0 1 1 something, and it's a 0.5 times R plus 1 for any R which is greater than of 1. So definitely this number, what will happen if R is my greater than 1, 0.5 times of this is also greater than of 0.5, but it is a 0.1. It is not satisfied. So it is not satisfied. It means there does not exist any R which is greater than 1 which satisfied this property. So that means this answer is only B and D are my correct answers. Okay, given that A and B and which of the following statement are true for sufficiently large n, means n approaches infinity. There are the two methods. Fine, there are the two methods you can solve it directly. If you know what is the computational complexity, or if you know what is the big O notation, then we all knows the rate of convergence of log n is always be less than of the n square, is always be less than of 2n, because 2 raised to power n growth faster than of the n square than of log n. So what is that? Because this number is my constant. This is my constant, that doesn't matter. So n 2 raised to power n means a n, log n, b n, and n square is my, that relation must be hold for that. So if you look about the option, a n is greater than c, correct option. C is greater than of b, but he said this is wrong. Bn is greater than of n, we will see. An is greater than of this is a correct. Now look at that, how you can find that relation, log n and n. So definitely log n is always be less than of the n, because n is greater than of the log n. So you can see from here, bn is less than of n, but he said greater than. This option is also cancelled. A and D are my correct answers. What is the second method? So we can check about the option. What is the an over cn as limit n approaches infinity? Fine. If I prove this is my greater than 1, then this result hold. An 2 raised to power n, cn n square. If you take as n approaches infinity, it's a infinity by infinity form. So if I apply the L'Hopital rule, this is my 2n. Again I can apply the L'Hopital rule, 2 square, or whatever the constants are there, this is over here, this is, and this is my 2. Clearly say this goes to the infinity. What does it mean? If numerator over denominator goes to the infinity, it means the numerator will grow faster than of the denominator. If I say bn over cn, what is my bn is? Log of n, cn is n square, and whatever the constants are there. Again it's infinity over infinity. I can apply the L'Hopital rule. Now it goes to the 0. When it goes to the 0, when the denominator part is greater than of the numerator part, but it's the opposite. Similarly bn over n, that is a log n over n, again it's infinity over infinity, so it goes to the 0. So this option is again cancelled. Similarly an over bn, an is this 2 raised to power, this is 2 raised to power n and log of n. So 2 raised to power n ln 2, 1 over n. So it goes to the infinity. So definitely this is the right answer is A and D. Okay, look at this one. An is a sequence of the real number, any sequence. It is not given that it's a convergent. It is not given that it's a divergent. It is again not given that it's a bounded. You can choose any of the sequence. Look at that. Whenever there is a term appear, I can choose an to be here. Then what is my first term? Minus 1 raised to power n. This is also minus 1 raised to power n. It's a 1. What is the mode of this? 1. So is this series convergent? Always remember this A is convergent only if A is equal to 0, and if A is non-zero, then it is a divergent. So this is my divergent. Or moreover, you can apply the nth term test. This limit is not goes to the 0, so it means it's a convergent, false option. There is a subsequence. If I consider again this example, if I consider any of the subsequence, say 1, fine, or minus 1, then what will happen of this? It is 1 over 2. Again it shows it is a divergent because the limit is not goes to the 0. So this option is also cancelled. There is a number b such that this will hold. There is a number b such that this hold, and there is a number b such that this subsequence will hold. How you can think about that? There is a number b. Okay, again if I consider this is my example, fine, then b minus n divided by 2, fine, into minus 1 of n. Now does it convergent? There is a b. How you can say there exists a b? Okay, there is, okay, if I choose n is my even, fine, or you can say this is my 1, this is a sequence, then this series becomes my b minus 1 over 2, fine. Now clearly say, because this is the alternating series, this will be convergent only when this part will goes to the 0, and this will goes to the 0 only when b is equal to half. But if I consider n is my odd, then this series will be my b plus half minus 1 raised to power n. So this will goes to the 0 only when b is equal to minus half. So you can see there is a number b such that this will converge. But if I prove this will divergent, then it is fine. How you can say there is a number b, there is a number b. Is the b is a positive or negative? It is not given. Okay, we can check out here if we can discard. Okay, there is a subsequence. So if I consider the subsequence is my 1, then this part will be my here. So definitely this is a convergent for b is equal to 1 by 2. So there is a number b. So this is a correct option. What about here? I don't know whether which of the following is correct. Only the one correct option is there. So definitely this must be the false. How we can say it's a false? If I take n is even, an is a sequence of the real number, then sequence of the real number, b is my here, it will be only when this, is it goes to the 0? It goes to 0 only when b is a negative, but there is no restriction on the b whether it's a positive or negative. So how you can say that? How you can prove that? Okay, we can think about in another way. We can start from here, b minus, but it's a modular sign, it's a modular sign. Okay, b plus 1 over 2 of minus 1 raised to power. Okay, fine. So this guy I can return like of this minus 1 raised to power n. If I open this bracket, it will be b minus 1 raised to power n, half is outside, minus 1 raised to power n. So clearly say this number is my constant. Fine, this number is my constant, so I can take this as a outside of the summation. So what is that? This will be my minus 1 raised to power n. So clearly say, is this the limit of this? This is my divergent. Why? Because the limit is not unique. Either it's a plus 1 or a 0. So limit is not unique. So that's why it is not a convergent. You can also take either as a plus 1. So the limit is not unique. That's why it's a divergent. So series, no, it's a series. Yes, it's fine because this is not a convergent series. This is a series. This is a divergent by GP test because common ratio is my 1. So that's why it's a divergent. Okay, look at this another one. Alpha is given to be here, beta is this. P is a polynomial of degree 2. Polynomial of degree 2. Ax square plus bx plus c. Fine. Okay, firstly look about that. What is this number? This is called as the golden ratio number. Fine. And if you look about here, can you find this relation? If this will be my root 5, then we call this as a Fibonacci series. Fine. The only thing we need to prove whether alpha minus beta is a root 5 or not. What is alpha minus beta? 2 root 5 over 2. Fine. So what is the meaning of that? Fn is my Fibonacci series number. So what is the Fibonacci series? What is the F1? F1 will be my 1. Fine. Now what is my P1? If I look about here, what is my P1 is F1. So what is the F1? And start from the 1. If I F1 is alpha minus 1. Fine. Then Fibonacci series 2, 3, 5, 8, 13 and so on. This number is my F1. This is my F2. So F1 is my 1. So what is that? P1 is my 1. It means A plus B plus C is my 1. What is F3? F3 is my 2. So F3 is my 2 means 9A, 3B plus C is my 2. P5, 3, 4, 5. This number is my 5. So when is 5? 25a plus 5b plus c is my 5. Fine. Now look at the option. This is the sequence of this is called as the Fibonacci series, and this is because of the 2 is a cancel. Then your target is to find the P7. So how you can find? I need a A, B and C. So clearly says if I subtract them, what will happen? It's a 8a plus 2b is equal to 1. And I can again subtract this number. 25 minus is a 16a. 5 plus 2b is equal to 3. Then I can subtract them. Minus 8a is minus 2. A is my 1 over 4. Once a is my 1 over 4, I can found from here is a 2 plus 2b is 1. So b is my minus half. Once a is 1 by 4, I can substitute here. So it is my 1 over 4 minus 1 over 2 plus c is equal to 1. So I can take 4 as LCM. So 1 minus 2 plus c is equal to 1. So c will be 1 plus 1 over 4. It's a 5 over 4. Fine. Now you get as a B, C value. Now what is the remaining part? You can easily get the value of P7. So P7 is 49 into A, 7B plus C. Fine. So 4 is the LCM. 49 minus 14 plus 5 is a minus 9. 40 over 4 is a 10 is the right answer. So correct options are A and D are my correct options. Look at June 2023. F of x is my 1 over 4 plus x minus x square, and xn is my this. So that means it is 1 over 4 xn minus 1 xn minus 1 square. Then which of the following is a convergent or here? So what is that? If I consider this is my L, so then 1 over 4 L minus L square. It means L is my plus minus 2. 1 over 2, sorry, is a 1 over 4. So now it has a 2 limits. So it means the sequence will converge either to the 1 by 2 or minus 1 by 2. How you can decide? We will look about the first non-zero term of the sequence. We will look first non-zero term of the sequence. If this is a positive, then it converges to the positive limit. If it is less than 0, then it converges to the minus here. So what is given to you? X naught is my A. Fine. Now firstly, the sequence does not converge. That's the wrong answer. Fine. If A is equal to 0, so we get a non-zero term. It means we need the x1. So what is the value of the x1 from here? 1 over 4 x naught square. If x naught is my A is my 0, so it is my 1 over 4, which is positive. Once this is a positive, it converges to the plus 1 over 2 is the right answer. Minus is cancelled. The sequence convergent, yes, for every A, and limit is 1 by 2 is fine. So clearly say whenever A is equal to 0, 0 is belongs to this, so it again satisfied. A and C are my right answer of this problem. Look at this another one. What is given to you? Which of the following is a convergent? Again the same concept. This is a 2n. This is 2n plus 1. This is 3n. These are my subsequence of the A of the xn. So as I mentioned you in the earlier tips, what is the mention I told you? If subsequence A and K converges to the same limit L, then only AN converges to the L. Now look at that. It is given that it has the same limit. So it converges to the L, it converges to the L, it converges to the L. It means xn is also converges to the L, and this is the right option. Subsequence this and this are convergent. What is the meaning of that? X of 2n is convergent to the L1. X of 2n plus 1 is convergent to the L2. X of 3n is convergent to the L3. Now if you prove each L1, L2 and L3 are same, then it means it converges to the same limit. How you can prove that? Very simple. If I choose any of the numbers, say let's say it's a 9. 9 is my odd number. If it is an odd number, it converges to the L2. But 9 is also the multiple of the 3, so it converges to the L3. But once it is a convergent, it converts to the unique limit. So what does it mean? L2 is L3. Similarly, I can choose any of the even number and multiple of the 3. So let's say x of 30. This is convergent to the L1 because of the even number. This is convergent to the L3 because of the multiple of 3. It means L1 is L3 because of uniqueness. Fine. So what is that? It means all are my same. So as per my earlier tips, if all the subsequence converges to the same limit, then the sequence is also convergent. Fine. Remember, if this is not given to you, for example, then clearly says this is convergent to L1, this is convergent to L2, then definitely L1 is not equal to L2. Then the option is wrong. Because if I consider my there, even is my 1, odd is my -1, both are not same. Look at this third option. What is given to you? X of kn. X of kn, that means x of 2n, x of 3n, x of 4n, and so on. If all are my convergent, then the sequence is convergent. Okay, right now it consists of the even, odd and 3n, but right now they are called as a 2, 3 and so on. Very simple again. If I define the sequence as when k is my prime and when k is my composite, so there is no repetition in that. If I define this is my 0 and this is my 1, so clearly says this is my bounded, it is my convergent. Fine. The subsequence, if I consider any of the subsequence, so what is that? The subsequence of this. So if I define the subsequence like of prime numbers only, so then it converges to the 0. If I consider the composite number, then it converges to the 1 only. So it means this is my convergent. Now does the sequence is also convergent? When it will be convergent? The sequence xn, if I consider any of one, let's say x7, what will happen? It is my only prime number. So what this means? It converges to the 0. If I consider as a 9, 9 is not a prime number, it is a composite number, so it converges to the 1. Fine. Now it clearly says if you have the sequence x1 up to the xn, so one limit will converge to the 0, another limit will converge to the 1. It means it is my not convergent because limits are not unique. So this option is cancelled. Fine. Look at this last one again. Because of the difference, either you can consider here, you can consider this, or you can consider this one. So if because I need to prove convergent, this is already convergent, I can take here, then this value will be my, if I take the sequence is my, so what is the limit? As n approaches infinity, I can rationalize them. It is n plus 1. So clearly say it goes to the 0 as n approaches infinity. So this property is satisfied, but this is my divergent sequence. So it means this option is cancelled out. Right options are A and B are my correct options. Look at one more example. Consider two sequence En and Bn, and which of the following convergent, does not convergent. Okay, look at that. I can write this term in terms of this n plus k, where k varies from 1 to n. Fine. Then your target is to check whether this sequence is convergent or not. I try to find the limit of this. If I got the limit as finite, then we can say it is convergent, otherwise not. So how you can solve this? As I mentioned you earlier, I can change into the integration. How? I can divide it by n on the both side. Fine. If I put x is my k over n, so then this is my dx over 1 plus x. When k is equal to 1, x will be 1 over n, and n approaches infinity is a 0. When k is equal to n, x will be 1. So this is my here. So what is the right answer of this? It's the log of 1 plus x from 0 to 1. It is my log of 2, which is finite number. So what does it mean? An is convergent. Last option is cancelled out. If it is convergent, convergence to the log of 2. This option is also cancelled out. Now, whether rate of convergence. Always remember the sequence 1 over n raised to power k. Whatever the k is there. Fine. K is my greater than of 0. Or you can say k is my of this. Then it is always convergent linearly, or you can say the rate of convergence is linearly. Remember, it is only convergent to linearly. Fine. So what does that mean? If I say Bn, it is k is equal to 1. So it means the rate of convergence is linearly 1. Again, you can see it's n plus k. It is similar of this. It means the rate of convergence is also 1. So both have the same rate of convergence. Fine. Does not have the cancel. A is my right answer. You can see my lecture of the order of convergence in my YouTube channel. You can find this simple proof of this result. So this is the way you can solve all these sequences problem in a nice manner. We will discuss the next lecture on the function of the several variable. Till then, you can simply like, share and comment on my video. Best of luck, students. Happy learning always.